Good morning. Wow. So many people in here. This is awesome. I'm very excited to be here with you all. This is, I don't know, like my third time back to Amsterdam, one of my favorite cities in the whole wide world. So this has been a great week for us to be here as part of Microsoft Ignite the Tour. My name is Jason Hand. I'm one of the senior cloud advocates on the cloud advocacy team here, part of the group that's here trying to show you some of the latest and greatest things that we're doing with Azure. What you're in right now is part of the SRE track. So SRE being Site Reliability Engineering. That's going to be a big key focus of a lot of the things that myself and everybody else that's part of this track is going to be talking to you about. How many of you are familiar with that term, Site Reliability Engineering? Is that a familiar term for some of you? Okay, great. So it seems like it is kind of new for a lot of you, so hopefully you'll take away some great information. You'll take some things that maybe challenge your current thinking when it comes to monitoring and trying to keep your infrastructure and your applications healthy. But with that, let's just dive right in. So obviously we're going to be talking about monitoring today, and I thought we'd lay out sort of our path for the next 60 minutes or so. So the first thing that we want to cover, in order to do any kind of monitoring, you always have to ask yourself, why? Why are we doing monitoring in general? Why do we monitor? Why is it important? And so we'll discuss some of the important aspects of why we monitor in the first place, especially around the idea of cloud. Most of us, I believe, are probably here because we're either starting to experiment with Azure or the cloud in general, and we're just trying to sort of bridge the gap and understand how do we move into this new cloud era. Maybe you're doing some sort of hybrid situation. Maybe you're still on-prem, but you're really curious and maybe ready to move to the cloud. And there's some different things that we have to pay attention to. So we're going to cover why it's important to monitor. And then we'll follow that up with what exactly should we be monitoring. There's a lot of things that have sort of changed since we've moved to the cloud, and I'm going to cover a lot of that. So exactly what we monitor is probably a little bit different than what you may think or have been doing previously. And then we'll get to the easiest part of this whole conversation towards the end of exactly how we're going to monitor. And it's almost embarrassing how easy some of the new concepts that SRE is bringing in terms of monitoring that really help us move closer to a real understanding of what our systems are actually doing. So that'll be our path, our journey today, talking about monitoring production applications in the cloud as well as infrastructure and that kind of thing. So I mentioned Site Reliability Engineering, took a little bit of a poll to see who was familiar with that. This here is our sort of definition internally within Microsoft, certainly within the advocacy team, those of us who go around the world and talk about Site Reliability Engineering. Of course, there are Site Reliability Engineers. You can be an SRE. There can be SRE teams. But we believe Reliability Engineering or Site Reliability Engineering is really an engineering principle. It's something that applies to all of us. We're all engineers at the end of the day. We're building systems and services. Some of us are more in the development camp. Some of us are more in the operations camp. But at the end of the day, we're all software engineers. We're building things. And then we're operating those things in production. And it doesn't matter if that's in the cloud or if that's on your, in your own data center or on a Raspberry Pi in a closet somewhere. When it comes to reliability, it really is something that all of us as engineers have to consider. So we like to tell people and remind people that this isn't a task for just certain people. This is actually a principle, an engineering principle that applies to all of us, anyone who's involved with building digital services. But there's two other aspects of this definition that I want to make sure we don't skip over too much. And the first part is this term here of appropriate. And if you read through the whole thing, it's about developing an appropriate level of reliability for the services and the systems and the things that we're doing. So let's talk about appropriate. In most cases, we like to think that we want absolute uptime for all of our services, all of the minor services, the microservices, the different things that sort of make up our system as a whole. We usually believe that we want all of those things to be operating at maximum uptime all the time. Well, it turns out that's probably not the case. What we want to sort of establish is what is a more appropriate, what is a more reasonable level of reliability, because in most cases, 100% really isn't necessary, and you're going to be spending a lot of extra effort, a lot of extra money, a lot of extra time trying to maintain 100% or maybe 5 nines of availability on something when it really just isn't that necessary. Now, that's not to say that there aren't systems, there aren't services and things that we do want maximum uptime. I flew over here on a plane just like all my other friends, and we want absolute uptime on those airplanes for sure. If you're maybe, you have some sort of pacemaker or some sort of other medical device that you rely on, you want those things to work almost all of the time. But I don't think that that's really all this, that's the systems that all of us in this room are building. Maybe some of you, but for the most part, we're building software, we're building things for our users, for our customers to use. And so we have to establish what is a more appropriate level. And it's probably not going to be 100%. And then the other part of this is reliability. It turns out reliability means a lot of things to a lot of different people, and it kind of depends on what you're building. So we'll go through a lot of different examples today, and you may be thinking to yourself, okay, this makes sense, but how do I do it for me? How do I decide what's the most appropriate level of reliability and what is important to me? Well, that's the question you have to ask yourself. I can't stand up here and tell you exactly what is the appropriate level, what is the main sort of parts of reliability that you should be considering, that you should concern yourself with. That's something you have to have a discussion with yourself and your team and your organization to sort of realize and figure out. So that's sort of our definition of SRE, and you'll see it throughout the rest of the deck here. Anytime you see a SRE with that little ribbon up at the top, these are concepts that come right out of site reliability engineering, okay? So that's what that means. So I mentioned we're going to talk about why we monitor. Let's get into the first thing. The first reason why we want to monitor is we want to make sure that our apps are actually doing what we expect, what I expect as a software engineer. Are they delivering on the performance? Are they delivering on the business value? Are they doing what I expect them to do? When I push new features out, when I push new code, is it doing what I expect it to do? So that's kind of reason number one. Reason number two is, are my apps and infrastructure doing what others expect? Of course, we want to make sure that our customers are getting the business value of the things that we're making. So we need to be able to monitor that and understand, is it really meeting the expectations of our users? And what are those expectations? And if we're off, how far are we off? So are my apps doing what other people expect? The next one is, we've all got goals, right? So maybe it's KPIs, it's OKRs, or some other format for sort of tracking our goals moving forward. But we all have goals, departmental goals, personal goals, the business has goals. Are we tracking towards those goals? Are we moving in the right direction? If you don't know, then it's hard to make good data-driven decisions on your business and make sure that you're doing the right thing for your customers and your business. So we're always tracking goals to make sure that those are sort of monitored and moving in the right direction. And then the last thing I have here is change. In the systems that we're building, even if you haven't moved to a cloud scenario yet, our systems are constantly in change, especially if you're starting to adopt a lot of the concepts behind DevOps, where we're doing continuous delivery, where there's continuous integration, continuous deployments. There's just things that are always changing. We like to sort of roll forward rather than roll back. No matter what, though, we're still going to be changing the system state back and forth. And then not to mention the changes that we make, our users are always doing things in our system that we can't always anticipate. So there's always change in these systems. They're complex systems. What's happening with these changes? Or maybe we pushed out a new change. Is it doing what we expect it to? So those are sort of the core reasons why we do monitoring in the first place. Now, this little diagram here is important, but we're going to start at the bottom. So let me just explain how this works. In terms of what we're looking at here, this is the hierarchy of reliability that was developed by Mikey Dickerson. And if you're not familiar with that name, this gentleman was previously at Google, and then during the healthcare.gov sort of project that was coming up in the United States when we were trying to provide affordable healthcare to a lot larger audience, a lot larger part of our country. The healthcare.gov system had some failures. It had a few problems as they were getting off the ground, some reliability problems. So Mikey came in and he suggested a few things, and obviously they got things working. But he brought forth a lot of interesting concepts. And the one important thing I want to share with you here is that monitoring is the most important part of reliability. It's the only way to really know if your system is doing what it's expected to do, if your users are getting that value out of it. So we have to start with monitoring when we're trying to build reliable systems. And then the next most important thing after monitoring is, what are you going to do when things aren't right, when things are broken? You have to have some sort of incident response plan. You can't just ad hoc sort of react to problems whenever they come up, problems will come up. These are complex systems. They are going to have failure. They're going to have small failures and large failures, but nonetheless, there's going to be problems that we have to respond to. And there's a difference between reacting to problems and responding to problems. And really the main difference is just being prepared and accepting, hey, there is going to be a thing happen at some point, and we have to be able to do something to fix these things. So incident response is the second area that's super important when it comes to reliability. And then the third one, which is often never done at all, is what we call a post-incident review, or maybe also known as a post-mortem. But all it is an incident retrospective. It's a gathering of everyone that was involved in the response and the remediation and sort of fixing the problem. Let's get all these people together and get all of their viewpoints, all of their diverse viewpoints of what they were thinking, what they were doing, what they were trying. And let's get that all together in one conversation, combined with data points about the different things that we were doing within the system as we're trying to troubleshoot. We're just trying to build a story. Exactly what happened from the moment we detected an issue to the moment we were able to recover from that service disruption. And let's talk about that in terms of a timeline and all the different things that went down. A lot of times people do root cause analysis. We don't believe that those are as useful as they used to, simply because there are no root cause in a complex system. So you hear people say root causes, which, I don't know, I'm a little bit stickler for semantics and for language. That doesn't make any sense to me. You can't have multiple root causes. Point being, we need to find different ways to understand what's going on in these complex systems. So we want to get multiple viewpoints, and a lot of it has to do with what were our engineers doing in those moments, because they have sort of these times where they have to make a decision, and they're under cognitive load, and they're under duress, and they're under stress. And so we want to understand, why do engineers make certain decisions under certain circumstances, given the knowledge and the information that they had in those moments. And if we can dig into that, there's a lot of data points that can really help us improve our incident response and improve our reliability of our systems. So that's our hierarchy of reliability. Now, let's take a few seconds here and talk about service level indicators. How many are familiar with this term? Service level indicators, SLIs, also SLOs. Okay, there's a few people in here. So service level indicators, we'll go into here deeply in terms of how to create those, but essentially we're just trying to establish an ongoing indication of the health of something within our system, okay? Now, when it comes to reliability, and building these SLOs, we have to determine, well, what does reliability mean to us? And I mentioned just a few minutes ago that reliability can mean a lot of different things. It depends on the systems that you're building. It depends on the company you're in and what they find to be important to their end users. And so you'll see, reliability comes up first and foremost in the form of availability. That's where most people kind of think first when they're talking about reliability. We hear things like 4 and 5 nines of availability. That's often set as like a target or some sort of SLA with our users and our customers. But reliability can mean availability. It can also have something to do with latency. Latency for sure has a lot to do with the reliability of a system. So those are two of them. We got throughput, coverage, correctness, fidelity, freshness, and durability. Okay, so and these aren't even all of them. These are just sort of the popular ones that most people think about when I ask them, hey, what do you mean by reliability? How do you measure reliability? What does it actually mean to you? Let's go into each of those just a little bit more in depth. This one I'm sure I don't need to spend any time on, or not much anyway. But availability, all we're wondering is, can the system answer a question that I ask it? Is it going to respond to me? Am I going to get a 200 okay? Am I going to get a 500? Am I going to get a 404? Am I just getting nothing at all? That's our sort of availability question. And then we talked about latency. Latency is super important, Slow is sort of the new down. We just don't have the patience for a slow loading page or slow loading application or mobile app or any of those things. We usually get frustrated if consistently the apps and the software that we're trying to use is just too slow for us. We'll move on and find a different service provider. So we have to start paying attention to things like latency. Throughput's another one, and this is all I mean here is, can you get the volume of data out, or the volume of data from one point to another? So can you move your data around the way you expect it? And is that even important to you? It might not be, depending on the services that you're building. Same goes for coverage. If you have something that's churning through a data set, is it making it through all that data? And is that important to you in the service that you're building? Correctness is another one. Did the processing that was performed do the right thing? I mean, did it even do what it was supposed to? Maybe it did something, but did it do what it was supposed to? Is it correct? Is that important to you? Is that important to your users? Fidelity is kind of a fun one to talk about because usually the example that I give is Netflix. They're a perfect example of being able to lower the fidelity or lower the certain measurements of their own reliability simply because they can turn off different aspects of their system. So maybe if you're in the main sort of navigation screen of Netflix, you can still scroll through and choose any of your movies or your shows, but maybe you can't search for a few minutes. Maybe the search aspect of that system or that tool isn't available, and you may not even notice. But what they're doing is they're turning off certain services until they can actually fix the problems while letting the rest of the service still operate. So they've lowered the fidelity, but we're still operating. Freshness is the data being served as quickly as you expect it. So when I go and query something, not only is there a latency concern, but how fresh is this data? Is this data actually sort of the freshest stuff that's in our database? And durability is kind of related too. If you were to write some data somewhere, can you get that back? That seems super important, right? If you're collecting records, all of these applications we write now have some sort of back-end database. Can you actually retrieve those if you need to? So those are all the things that kind of make up, or not all of them, but a lot of them anyway, that make up reliability. And so when we're talking about reliability, please don't always assume that it's just availability. There's a lot of other things that kind of go into making sure our systems are performing and they're delivering on the promise that we've made to our end users. But one important thing you always have to keep in mind is this isn't about us and the measurements that we see. It has to be more about what the customers are experiencing. Because we may have all kinds of monitoring in place and all kinds of things that we think are really indicating to us the health of a system, while yet our other users or our users in general are experiencing something completely different. And a lot of it is because of the way we measure or what we're looking at and how we're collecting this data. So we always have to put the customer first and try to look at it from their perspective, which is often difficult. But that's sort of the new challenge, is how can we see what it's like for an end user? So I mentioned SLIs. Now we're going to talk about how you actually develop an SLI. And this is something that's actually going to help us understand what it's like for that end user because we can start to play around with where are we going to collect this information, what's actually going to be a good indication of what they're experiencing. So an SLI is pretty simple. This is like math from childhood. You know, it's all just kind of simple fractions, but all we're doing is we're taking one thing, a number of, in this case, we're looking at successful HTTP calls, and we're just dividing that by the total number of HTTP calls. And that's going to give us a ratio. It's going to give us a proportion. We'll do some basic math at the end to sort of get our percentage. But all we're doing is just taking numbers and dividing them by a total. So another example could be the number of operations that completed in under 10 milliseconds divided by the total number of operations. And you can see there's other examples here. Number of records processed divided by the total number of records, et cetera, et cetera. But what we're doing is getting a basic fraction, and then we'll multiply that by 100, and that gives us a percent proportion, which usually ends us at something like 99 point whatever percent availability, or 99 point whatever percent, or maybe it's not even in the 90s. Maybe it's something like 80s or even lower. But anyway, that's how you calculate these SLIs. Now, there's one thing that you have to kind of be really sure you all agree upon. You have to have this conversation across your entire engineering team and say, well, where are we going to get these numbers? If we're going to try to simulate or replicate what it's like for our end users, what data can we collect and where is that data? And you have to have these conversations and decide, well, maybe we want to try to get this stuff from the server. Maybe that's where the data is, and we're just going to go and directly sort of query information, query logs, query whatever from the server itself. Or maybe we're using some sort of aggregator or a log collector, and the data is being pushed over into another place, and we have to sort of look at the information over there. There's lots of different places you could be, I guess, getting these different things. But you have to come to these decisions. Maybe you decide it's not from the server. We don't want to get that information from the server. We actually need to get it from the client. The client's going to tell us more about what it was like for our end users because we're way over here recording metrics at the things that we see, but they're over in a different part of the world or, certainly a different part of the country using your application. So what's it like for them? We have to move ourselves closer to them. So if it's not the client, it's not the server, what else? It could be the application itself. You got a mobile application, okay? You got your browser, mobile applications. There's lots of different places you can get these things. Another really good one, and in fact, the one I usually talk about in this example is maybe it's the front end. And when I say front end, I'm talking about a load balancer. As far front end as you can get to the user, maybe that's where we need to get the data from, because that's going to tell us a few things that wouldn't end up on the servers if there is some sort of a problem. So we're always looking for that. And then also maybe it's the information that's coming out of our monitoring and our testing systems. Those might be good places for us to sort of collect those numbers and start calculating what our SLIs are. So those are where the numbers come from. But then there's also the important aspect that you have to decide, hey, we really need to come to the same agreement. It can't be just like one or two people saying, we're going to collect this from the load balancer and nobody else really needs to know that. Everyone has to be on the same page about where this information is coming from, so that when we have conversations about SLIs and SLOs, we all know where these numbers are coming from. So maybe they're coming from the load balancer in the example of the HTTP calls. In my example of the number of operations, maybe we're getting that from the client. Other options, we could be getting them from the server, could be getting them from the log. The point is, they could come from lots of different places. There's no right answer. I can't come up here and tell you exactly where to get these things, because it depends on the systems and the things that you're doing and what expectations your users have. So let's now kind of pause and just go over the math of how we develop these things, just to make sure everybody's sort of on the same page here. Let's say we've got, in a snapshot of time, we've got 85. I know that's super low, but we've got 85 successful HTTP calls out of 100 that are coming into our system here. That gives us a ratio, 0.85, right? 85 over 100. Multiply that by 100, and now we have 85% availability. Everybody understands the math, right? That's not too complicated. That's why I was saying at the very beginning of this, it's almost embarrassing how simple some of this stuff has become, because we don't have to worry so much about CPU stuff. We don't have to worry about disk space. We don't have to worry about memory. And when I say we don't have to worry about that, please don't take away from this talk that Jason was up here telling me I don't have to monitor for those things anymore. That's not what I'm trying to say. What we can do, though, is we can put in some automation, and we can make sure that Azure or whatever services we're using can take care of those problems for us. If we start to run out of resources, if we get low on processors, if we get low on disk space, well, we can just have the system detect that automatically and just go get things for us on demand, which means we don't have to page humans in the middle of the night. And that's a huge deal. As our systems get larger and more complex, we have to make sure we're being humane about our on-call practices. And if you're alerting people of all kinds of noise and things that aren't actionable, things that they can't do anything about, people are going to get burnt out. They're not really going to be able to sift through the noise and find the real problems in their systems. So you got to be smart about how we're alerting people and what we're alerting people on. So we've got to talk about where those numbers are coming from. And like I've mentioned already several times, there is no right way. I can't give you the answer up here. It really depends. But you have to understand that there are trade-offs. So if you decide that you're going to get your information from the server rather than from the client, or rather from the front end, or let's call it the load balancer, you have to understand maybe you're getting more information about one aspect of your system, but you might be sacrificing information from another one. So you understand the trade-offs a little bit. And to sort of illustrate this, let me just show you this little thing here. So let's say, for example, I wanted to know how many requests I was getting from a server, or from requests getting sent to my application. And then I want to know how many of those were bad, how many of those were errors. Well, this probably seems pretty common here. We've got all of our users coming in, they're sending packets in, they're interacting with our system. And so we ask our server, hey, how many requests and errors do we have? We got logging enabled here, maybe application insights, but we're collecting all this stuff. And so I ask my server, hey, how many requests do I have, and how many of those are errors? And the server spits out its log file, and here you go. Good luck with this, and see if you can figure out what answers to the questions you have. And that's kind of how we do it. It makes perfect sense. Our logs should give us the information we want. We can start doing our calculations. But maybe consider this scenario where it's the exact same thing, but we ask our server the same question, except the server doesn't have all the answers. It doesn't have any knowledge of the packets that never made it to the server. So this is what I'm trying to say. You have to decide for yourself, where does this information come from? Because in this scenario, I don't have all the information. If I'm going to try to strip this out of my log aggregator or whatever tool I'm using on my server and it never got the packets for whatever reason, then I'm not looking at reality. I'm looking at what I think is going on, but it's not what's really going on. Does that make sense? So you have to understand more about your system and where can we get the reality. We're trying to build observable systems, and an observable system is one that you can ask any question and you almost have absolute faith that the answer you're going to get back is reality. It is the truth. There's no guessing. There's no, I don't know if I believe it. We want to create a system where I can go in and ask questions and I believe my system. And that requires a lot of effort. You have to do some different type of instrumentation. We have to set up some things like SLIs and SLOs. So we've talked about SLIs. Why don't I give you a little bit of example of how we can build an SLI, and I'll do that over in Azure. So let me switch over to our portal here. And I'm going to go into application insights so we can get into log analytics, okay? So actually, before I do that, I want to grab one quick query. So let's go into application insights. Application insights is, to me, one of the more powerful components of Azure itself. We've already established that monitoring is the most important aspect when it comes to building reliable systems. So if you're going to move things to the cloud, if you're going to move things into Azure, you're going to want to use application insights. You're going to want to have things instrumented so that you have an observable system. You can go in and ask it questions. You can see how many failed requests you have. What's the server response time? All the server requests in total. These are the things that are just there in your dashboard automatically. But the nice thing, or the awesome thing, the most powerful thing that I think is part of Azure Monitor and application insights in general is the log analytics. So we're going to go into log analytics. And what log analytics is, it's just a query analyzer, query editor for me to go in, and we use a querying language called Kusto, so KQL, Kusto querying language. And it's not that different from SQL, if you're familiar with using SQL, but it is different. But it's pretty easy, and it's pretty straightforward. The way it works is we've got all these tables over here that are automatically collecting data through us for us if we're using application insights. And we can come through and kind of click and create queries as we want them, or we can manually type them in. I'm just going to go ahead and paste in this one here, and then I want to explain it to you. Let me zoom in a little bit. Let's talk about this query. Because this is going to help us design, or help us sort of develop visually an SLI of what our system has been doing over time. So what we're doing is we're going into our requests table, okay, because we're measuring HTTP requests. And we want to see all of the requests where the timestamp was greater than 30 days ago, okay? So we're looking at rolling 30 days. And then we're going to summarize a few things in here. So we're looking at the count, or we're creating a count of the total number of successes within our requests table. So anytime success equals true, we want to count those up. Same goes for failed. Anytime there's a success that's false, we're going to call that failed, and we want to count on that. And then we're also going to total up just all of them in general, all the different requests in general. And then the way we have this sort of bucketed is currently by 1 hour, and I can show you that we can change that, and it'll change the way that the graph looks and everything, but we're going to start with 1 hour. So that's just doing some summarizing, some calculations on the numbers, looking at our requests. And then on the next line, what we're doing is this extend part is it's going to actually allow us to sort of export out and display these fields that we've now created. So we've created this success field, we've created this our succeed field, we've created the failed field. If I want to be able to show those in any part of the table that shows up below all this, I have to use the extend, as well as the next line, which is project. So we're going to extend SLI, which all we're doing is taking the succeed value from the above the previous line, multiplying that by 100, and then dividing that whole thing by the total. That gives us our SLI. And then we can display that stuff using project the SLI and the timestamp. So let me just show you what that looks like. If I come in here and run this query, scroll my screen up just a little bit so you can see it all. Actually, let me shrink it so you can see it better. So what we've got here is a nice little graph that's showing us our service level indicator over time, over the last 30 days. I don't actually think this system was running for 30 days, so that's not quite true. But nevertheless, you can see that if we're measuring HTTP requests, it kind of dances around a little bit. And all it's doing is that basic math of how many were good, how many were bad, and how many were their total. But you can see it kind of hovers around a little bit above 90. We're at 91 here, 92 there. Some of our low points are around 86. There's an 86 there. Something really went wrong here. I don't know what happened, but we got down to 72. But there's a lot of activity. And if we were to change this from 1 hour to like maybe 5 minutes, it actually gets so crammed together that you can't really make much sense of it. But you can see that we can look at this over different sort of time periods, okay? To me, 1 hour is sort of what I want to know. I'm gonna get these things and just sort of look at them within 1 hour buckets. Let's change that back. And that's really all there is to it. If you wanted to see the math on this, what we could do is go ahead and add, let's see. Actually, just to save time, let me just copy and paste it out of my little notes here. Let's go down. Take this guy out. All I'm doing here is just throwing in a couple more fields. We want to see what the succeed and the failed looks like, just so we can kind of, I guess, check our math and make sure we understand what's happening. So you can see these numbers kind of show up down here. If we take out the time chart, we can actually see it in more of a table view, which is often a little easier when you just kind of want to look at the numbers and compare things. So our SLI is being calculated at a little under 90% here, and it's taking 317 successes, 36 failed, doing the math, and that's how it comes to the 89, okay? So that's kind of nice just to see if you can, or make sure you understand what's happening with the calculations. So let me take those succeed and failed back out. All right, so that's an SLI. That's just one example of an SLI, but it's super simple to create one using log analytics, and you can kind of add that to a dashboard, and you can always see at any given point as you're walking around your office, you're walking around your team's space. Okay, it looks like our SLI is mostly in check. It's a visual aid. So there's a lot of things in log analytics and application insights in general that I'm not obviously going to be able to cover today, and I had a talk yesterday, and I've got another one right after this, and even with all three of these, there's just no way to really get to all of the different things that you can do within log analytics and application insights in general. This doc here is actually one of my favorites as far as a good starting point. If Azure Monitor is fairly new to you, but you're curious about this stuff, this looks interesting, this is where I would start. So these slides will be available. I'll give you a link at the end, but this is the place to go to learn more about Azure Monitor. So I highly suggest you do that. So we just talked about SLIs. Now let's talk about SLOs. And what we mean by SLO is an objective. It's a service level objective. And we have to look at this from the customer's point of view. Obviously, it's an objective for us because we're trying to build something for our users that has value. And so we want to understand, what are they trying to do? What is their objective? And we're going to set our objective, our kind of line in the sand, in terms of the movement of our SLI. We're going to set our line in the sand, our threshold, so that if something seems off because suddenly our SLIs have drifted below our threshold, then it's time to get people involved. Something is definitely not right because our SLIs have dipped below the threshold. So that's what our SLO is. It's simply just the desired threshold that we know if something passes this line, it's time to get people involved. It's time to page the on-call first responder and sort of see if we can dig in and understand what's happening. Now, when people will ask me, okay, makes sense, where should I start monitoring? I always have to remind them that we now want to start monitoring as close to the user as possible, okay, which is often difficult, especially when so many of us are used to monitoring on the applications, monitoring on the infrastructure, and only monitoring there. For us, for many years, if the infrastructure wasn't working right, if we were running out of disk space, if we had a memory leak, all these types of things, that's a leading indicator, or that's definitely some sort of indication that we will probably have a problem with our application at some point. But you also have to remember, you may be pegged across the board in resources. Everything's being used or almost used, but yet our users and our customers are still able to do the things that our system is designed to do. Especially in the cloud, that's a very reasonable possibility that everything looks bad, but to the user, it's all fine. So that's giving us a false impression of what's actually going on. That's not reality. That's not a good observable system. So we have to find different ways to move our monitoring closer to the user experiences that they're actually having. So how do we build a good SLO? Well, this is our little basic kind of recipe. on taking a couple different things and mashing them together to create our SLO. So the first thing we need to build an SLO is we have to determine what's that thing that we're monitoring. We talked about earlier, is it going to be HTTP requests? Is it going to be storage checks? Is it going to be the number of operations? Doesn't matter. When you're creating your SLO, it's going to be one of those things, okay? What's the SLI component of this? Then we look at the proportions of the SLI. Okay, so in maybe one example, we're successful 50% of the time, and that's exactly what we want our SLO to be. Might seem low to you, but it might be okay for one part of the system. Do all of your systems need to be up at 100% all the time? No, we've already covered that. That's not a reasonable amount of availability or reliability in general. So you have to determine. Maybe it's 50%, maybe it's 99, maybe it's 5 nines, but that's the SLI proportion. That's the ratio part of it. And then the time statement is also really big. I went with 30 minutes, like sort of a rolling 30-minute average. You could do 30 days, you could do 60 days, you could do 5 minutes. It's all up to you. What is going to help you understand what's actually going on with your system? But you have to have the time element. So we've got an example here, 90% of HTTP requests as reported by the load balancer. That's an important thing. We all have to make sure we know where these numbers are coming from in the last 30 days. And that's how we build our SLO. It's super simple. We're just creating a sort of a threshold. What's okay for us? What's not okay for us? If it gets past 90, then it's time to get people involved. Now, obviously these are super simple. Maybe too simple in terms of your infrastructure and the systems that you're building, but you can get more complex. There's other ways that you can build SLOs. You can start doing compound SLOs where actually you have sort of an upper and a lower bound on your threshold. Maybe 90% of reads last week took place in under 10 milliseconds as reported by your disk checker, but also 95% of last week took place in less than 20 milliseconds. Maybe you've got some sort of interesting, complex, compounded SLO where it's actually, we don't want it to go below a number, but we also don't want it to go above a number. Or maybe there's two different baselines that we don't want it to go through. We can also do segmentation. We can do maybe the 95th percentile of HTTP requests is of the 100% of all of the availability or all of the requests that are coming through. Maybe we're okay with 95% being good and then 5% being bad. And you can do some sort of different percentiles there. So you can get complex with your SLIs, although I would recommend keeping them pretty simple to begin with. So when we're determining what is our SLO, should it be 90? Should it be 85? Should it be 5 nines? How do you know? How do you determine these types of things? A lot of it comes from what are the expectations of the user. And they're not going to be able to give you a number, of course, but they do have expectations about when they can get in, maybe pay some bills on their online banking, maybe go in and book travel. There's all kinds of reasons why we use digital services. We have to understand what their expectations are. So we have to go and look at customers. Maybe they're external customers, but maybe you're also internal customers. Maybe a lot of you are building systems simply for your business. And so your customers are just the people in finance, the people in accounting, the people in inventory, whoever it may be. Those are still your customers. They're your users. So they're going to have some expectations, and you need to kind of have these really good discussions with them. What is it that you're trying to do, and what's a reasonable amount of downtime if we experience it? You may also have what I call, in quotes, just some other data. And all we mean by that is other aspects or limitations of the system have thresholds that we have to pay attention to. Maybe there is some part of our database or the database that we choose to use has some limitations on what it can collect for us or what it can do for us. Maybe we have to consider those in terms of when we're setting our SLOs. One piece of advice I will give you, though, is be very, very cautious of boxing yourself into a number that you really don't even understand. So let's say, for example, one aspect of your system is running at 99% as far as you can measure availability. And that, it's been running like that for like 6 months. So to us, this part of our system is actually pretty reliable. It's mostly up all the time. As far back as we've measured, 6 months, it's up almost all of the time. So why don't we just set our SLO at 99% or whatever number we've measured we think it's going to be at? Well, you can do that, but what you've done is you've just sort of boxed yourself in to keeping availability or whichever element of reliability you've chosen at the highest it's ever been for that one service. So I don't want to discourage you from using high numbers. Swing for the fence, go for the best you can do, I guess. But also remind yourself or remember that you may be setting the bar higher than it needs to be. If we go back to what's sort of a more reasonable level of availability, it might not be 3 nines. Maybe you've just set a bar that you might be able to maintain, but it's going to take some extra effort. It's going to take some extra money. Also doesn't leave you with much headroom to actually go and do some improvements and find other new ways to develop software and maintain software. So you want to be able to find ways to set actionable numbers that make sense to you. So be very careful about kind of painting yourself into a box. All right, so talked about SLOs. Now let's go back over into the portal and I'll show you how you can visually see an SLO as compared to an SLI. So we're back in here, we're looking at our query. Now, what I'm gonna do is I wanna create a line across. Let me show this as a visual first. Let's get our original query back up here. So we see it as a visual line here of our SLO dancing around. Let's add in the SLO, okay? So what I'm gonna do now is just add another number here. And I'm gonna say, or another value here, I'm gonna set my SLO at 85. So we're creating a new field here, setting a value to it, and then I need to project that out. So let me add SLO to the query, and then let's rerun it. If I scroll up, you'll see we still have our SLI, but now we've got this line in the sand. We've got our threshold. This is the thing that tells us whether we're healthy or not. So long as everything's above that line, I'm okay. I don't want to be paged about a problem if it gets down to 89. Even if it's 89 for an hour, I've already determined I'm okay with that. But the second it gets below 90, now it's time to get people involved. So we're just setting that bar. We're setting that threshold. Where is it time to get people involved? And that's all we need to do in terms of creating a visual aid. I think it's a great idea to make as much of our work visible as possible. So obviously we're using things like Kanban and lots of different ways to communicate the work that we're working on, but it's also important to communicate the observability of your system and as much information about your system as you can. So you go around a lot of startups, where I was working before I came to Microsoft, and there's dashboards all over the place that are telling people what's going on with different aspects of their system. It's very important to kind of know those types of things. So this is a great way for you to create a visual aid that kind of shows your SLIs and your SLOs. But at the end of the day, we need someone to get involved. We need people to be paged if it does dip below that SLO line, and having a visual aid is not going to do it for us. So what do we do then? Let me pop back over and let's talk about alerting people to problems first. Oops. So actionable alerting is something that I talk about all the time. And you can probably tell by all the gray hair, I've been on call for a good portion of my life. I have some thoughts and feels about what it's like to be paged in the middle of the night when it's not something I can do anything about. If you page me, there better be some method for me to go in and make a difference. If I don't have access to the systems that are experiencing a problem, that's no good to anybody. Or even worse, if you're gonna page me about something that actually happens every night around 2 a.m., but then it clears itself up every 20 minutes, don't need to be paged on that either. So you have to be very mindful about what's being paged out to people. And we wanna make sure it's always actionable. And some of the things that I see very common, especially for those of us who have been doing this for a long time, we've brought ahead a lot of bad habits from the way we used to monitor. And I've mentioned several times now, in the cloud, we don't have to necessarily page on things like, CPUs being maxed out and disk space running low. We can set up triggers to go and just get more services. So there's some differences in the way that we do this stuff now. And so I see a lot of anti-patterns out there still, because this is just the way we've always done monitoring and the way we've always alerted on problems. The things that you should be alerting on have to be actionable. It's got to be something somebody's going to do. And if it's not, then it's really just a log. It should just be logged into a file someplace. It can be used to be part of an investigation into an incident later maybe, or just part of data that you can go query on at some point. But if it's really just something that should be logged, let it go to a log. Don't page a person on that. The same goes for just sort of general notifications. It's like if you're doing continuous deployment, you shouldn't necessarily be paging out every time there's been a deployment. Maybe that's just an alert that goes into Teams or goes into Slack or it goes somewhere. Maybe it could be an email, but you don't want somebody to context switch and have some sort of knee-jerk reaction to things that are really just need to go into a log or it's a basic notification. It's just information. Another bad habit I see also is people using heartbeat methods to see if their systems are up. We don't want to ask our system, hey, are you up? Hey, are you up? Hey, are you up? That's a lot of noise. It's a lot of noise to try to make sense of. We don't want to know when things are normal. That's what a heartbeat's for, right? To tell you that things are normal. We don't want to know about things that are normal. We want to know about things that aren't normal. So anything that's a heartbeat it's not an actionable alert either. We're looking for things that are outside the bounds of what a normal system is doing. And so normal systems should be collecting logs, should be putting things into logs. They should be generating notifications, but those are not to be sent to the first on-call responder, the person that's on call. So please don't continue those bad habits. I was guilty of that for a long time, just because that was how I did it when I was using older software on different type of architecture. But things are different these days. We want to make sure that whatever's happening, this is something a person needs to go do, okay? And ideally, they should be able to fix it. They should be able to have context to know what's going on. They should have access into systems and make sure that they can actually go and do something positive. Not only that, but it needs to be the right human. Another bad habit I still see too, where maybe we've moved from an on-prem or our own data center situation into the cloud, is we're still letting network operations centers or tier 1 support be our first responders. These people don't know our systems. We're the ones that built this stuff. We have to be the first responders, and it has to be the right person. So your first responder to maybe a problem that's about a database shouldn't be a tier 1 person on the other side of the world who knows nothing about this database. We're talking about an urgent issue. There shouldn't be people typing up tickets. We need engineers involved right now. We needed them involved a few seconds ago because there's a big problem with our system. So we want to make sure that not only are humans being involved, but it's the right human. And it should be, if it's going to be a person involved, it shouldn't be something that can be automated. If there's an automated way to fix that problem, that incident that's come up, then we should automate that. So anything that's coming out in terms of an actionable alert is something that humans have to be able to do. And then it also needs to be pretty simple. I was super guilty of creating all these alerts, trying to add all this extra context and as much information as I could to my alerts, but I was actually making it too complex and too verbose. We want to keep our alerts pretty simple. We want to tell the first responder, here's what's going on, here's the SLO that has been breached, here's the services that are impacted, here's what the customers are likely experiencing, and here's your first 1, 2, or 3 steps that you should try to understand what's going on with their problems. So that's actionable alerting. And in terms of that context that should show up, we want to know, again, where are the alerts coming from, what expectations or what SLO has been breached. Why is this an issue for the customer? Why do I need to get out of bed and do anything? Because if I don't know, I might not respond the way that I need to. If I know how customers are being how they're experiencing this issue, then I have that context and I know what I should be doing. And then, like I said, also, what are the first couple steps that I need to be doing? So let's hop back over to the portal and I'll show you how you can create some alerts based on our SLOs. So we've got our SLO here. We see our SLIs. This is great for visual aid. Put it up on a dashboard, throw it up in the corner. Everybody can see how we're doing as they're kind of walking around the office. But that doesn't help us when something goes wrong, when it actually dips below the SLO. So let me make this a little smaller here again. And what I'm going to do, here we go. Let me just start a fresh one so we can see everything right. If I take my original query Over here on the right, we see this option to create new alert rule. So I'm going to go in here, but there's going to be a few changes that we have to make. So I'm going to explain those in a second. But first, we're going to click on Create New Rule. And what it's doing is it's asking me what's the resource. Because we've already started developing and creating a query in the first place, it knows exactly what the resource is. But you can see here by this red indication that we've got a problem with our condition. And what that's telling me is that there's something not quite right with the syntax of the query I'm using. So if I click on this, it takes me into a new blade, new part of the screen here. It's not going to be able to display anything up top because the query is not right. But if I look down here, let me try to zoom in a little bit. This is the query that I initially put in there, and you can see it's still chugging along on this, but it's not going to like it. It's got a syntax in there, or a syntax error in there. So let me go over real quick and just grab the good query, and then we'll discuss it real quick. So if I delete this out of here and drop in a good query, zoom back out real quick, you'll see real quick, we've got our green checkbox, or green check mark in the box, lets us know that this syntax actually looks pretty good. The query up here, the visual aid is not going to show anything because nothing's going on in the system just yet. But if we scroll down now that we have that query in here, what's going to happen is Azure and Application Insights, Log Analytics is going to run this query at some interval of time. And we're going to set it for 5 minutes, but it's going to run it every 5 minutes. And if it determines that it's below the SLO, then it's going to alert on somebody. And so to do that, what I had to do in my query, let me zoom back in so we can talk about it here. It's the exact same query that we used earlier, except we took out the SLO because we're going to establish a different way to alert on or create that threshold. But we've added another thing in here called the aggregated value. And what that does, it's created another drop-down box below what we can see here on the screen that allows me to choose the SLI as the thing that we're going to that we're going to actually trigger on. So it'll make more sense here when I show you these options here. So we're going to go, alert logic is going to be based on a metric measurement. We're aggregating anytime it gets less than, let's just say 85, okay? So this is basically our SLO. Anytime the metric measurement that we're measuring drops below 85, and then we have the option of total or consecutive. I'm going to say total. It's going to be different, might be different for you, but anytime the total is greater than 0, because this is super important. Anytime, for me, anytime this happens, I want somebody to be notified about it. But you can set it up so that, hey, maybe every 5th time it's happened, then you want somebody notified. So whatever you think is appropriate for you. And then this aggregate field is what that aggregated value part of the query has allowed us to use. So it created this little drop down here, and I'm going to choose SLI as what I'm going to aggregate on. And then the period, like I told you, over the last 5 minutes, this is as granular as you can get for now, is every 5 minutes this query will run, analyze your logs, and if the metric measurement is below 85, it will trigger an alert. If it's below 85 even one time within those 5 minutes. So that's sort of the logic behind the query itself, or what they're calling the condition. Now, the next step is for me to actually create the action group. Like, what's going to happen when the SLO is breached? So if we come over here, I clicked on creating a new action group. What I'm going to do is, let's just say SRE20. Call this SRE20. Give it some name. Give it a name, a short name. I'm in the right subscription group. Come down here and I'll find my SRE20 resource group. And then the action name and the action type, these are the things that are actually going to happen. So when that SLO is breached, what do you want to happen first? Now, I've already talked about alerting that first responder. I personally like to make my first step actually to create a clean space, a place for all of our responders and their engineers to have a discussion about what's going on. And if you're curious about how that can be done, I encourage you to go check out SRE50 later in the day. Emily Freeman's going to be giving that talk, and she'll show you how you can actually establish some different things in terms of setting all that up. So I'm not going to spend much time on it because she's going to cover all that. But what I like to do is actually say alert first responder. And for me, I'm going to go ahead in this demo anyway. I'm going to choose email, SMS, push, and voice. Okay, but we've got lots of other options here. We could do a logic app, webhook. You could send a JSON file over to a webhook. You could do ITSM. If you're going to do that, then you can hook up tools like VictorOps or PagerDuty, which help you with sort of your on-call teams and incident management through there. But you've got several options. But let's just talk about email for a second. Now, I don't know about you, but I don't wake up to emails very often. So I don't think email is the appropriate place or the appropriate method of delivery for an urgent alert. Maybe it is for you, but in my opinion, alerts should not be an email. What I'm going to do is actually come down and choose a phone number. Please don't call that number. I just made that up. And so this is what I want to happen. I want my first thing to happen is to actually call me, because at that point, I'll know something's not right. I'll wake up in the middle of the night. And so that's what I'm going to do. And then I come down here and I'll hit OK. So we've got our action group name. It's been created. I can add a few other things in here about adding a subject line. I need some details. SLO has been breached. Give it some more detail in the description. What severity we want this to be. In this case, I think this might be a Sev 1 at least, because we've got some issues with our availability. Can enable the rule upon creation. Yes, want that handled. So I've just created the rule, okay? So now, moving forward, anytime, every 5 minutes when it looks at it, anytime that has dipped below 85 for our SLO, I'm going to get a phone call about it. And that's exactly what I wanted, okay? Back to the actionable things, hopefully you're sending more information either into a Teams channel or a Slack channel that contains more context. Like I said earlier, what SLO is broke? What's being impacted? How are the users, what are they experiencing? What kinds of things are going to be helpful? Those should be delivered in the actual page themselves. All right, we've got just a little bit left here. Where do we go from here? What's the future of monitoring look like? Some of this is kind of the future. It's definitely the now and the future, but there's more coming. So what are we looking at? How do we sort of prepare for the stuff that hasn't been discussed here? Well, a lot of companies out there have recognized that there is no silver bullet. There is no one magic tool. Application Insights and Log Analytics and Azure Monitor as a whole is a great tool. Don't get me wrong, but maybe it's not going to be the only tool you use, and that's perfectly fine. That's how most companies look at it. There isn't going to be one that solves all your problems. So sometimes it makes sense to integrate in multiple monitoring solutions. Modular monitoring solutions as well. Things that maybe they can be stacked on top of each other, not just being monitored from different angles, looking at different things, but things that actually play well together and sort of collect information together. Same with the aggregated monitoring. Maybe we're going to take, rather than all of the components of a billing system, maybe we're just going to measure the billing system as a whole. Maybe we aggregate ways together, or we aggregate ways of monitoring our systems as more of a whole. Of course, anomaly detection is something that's becoming very popular. We've got some aspects of anomaly detection built into Azure Monitor and Log Analytics and Application Insights, where it uses machine learning to actually establish a baseline of your system and kind of create what it believes your SLO should be. Like if it's going to behave this way over a certain amount of time, we will make some suggestions about that. And if we see it get out of bounds, that's an anomaly, and we'll see if we can tell you about that. And then the question that always comes up is, well, what happens if monitoring's down? How do you monitor the monitor? And then, more importantly, if everything goes down, including monitoring, what's the first thing you should bring back up? Do you bring your applications up? Do you bring the infrastructure up? Do you bring the monitoring up? In my opinion, monitoring should probably be the first thing that comes back up, because it's going to tell you what the rest of the stuff is doing or isn't doing. In the minute that I have left here, I want to thank you for coming to this talk. There's so many things I wish I could have told you, but in just the 60 minutes, doesn't even feel like 60 minutes, I've only been able to really just scratch the surface. But I've got another talk immediately after this over in Elysium, so I'm going to book down there and get set up for SRE 30. We're going to be talking about sort of the continuation of this story. Now we've alerted a person. It's time for them to come in and diagnose, like troubleshoot. What is the what's going on here? What are the contributing factors to whatever's causing this breach of SLO? Following that is SRE 40, which is, again, the continuation of the story. Maybe we've determined we've got some issues with our resources. We need to set up some auto scaling. We need to make the system be able to do those sort of automatic resource grabs like I was talking about. And then SRE 50 is all about incident response and then doing your post-incident reviews, which I think is one of the more important aspects of this whole thing, is you can't just have these failures and then not discuss them and not get learnings out of them. You've probably already seen this slide a bunch. You can go get all of the slides and all the talks and all the code from these repos. But I would ask that you start having these conversations with your teams. What should a good service level indicator be for us? What should be a good SLO? How do we measure those things? And last, I asked you that you give me some feedback on this talk. How can I make this even better? I travel all over the place teaching these things, coaching people on SLIs, SLOs. I've been part of this tour now for about 4 months. How can I make this better? What didn't I cover? What can I do to make the next time I give it a little bit better? So please give me some good feedback, and I appreciate anything you can help me with that. With that said, thank you so much. I appreciate your time. Follow me on Twitter. I'd love to be friends. And thank you so much.